Welcome to the seventh of these Academy sessions. What we're going to focus on today is first off looking at kind of we're going to do an overview of the entire architecture of ELIZA. ELIZA is our sort of flagship project for making an AGI construct with cognitive architecture. A lot of mouthful of words there. AGI construct. It's artificially generally intelligent. It reasons, it plans, it picks skills, and to execute tasks based on its own thinking or simulation of thought using transformers and such. Cognitive architecture is kind of the way we frame that and build that reasoning, planning, task handling loop is the cognitive architecture. Cognition is really taking in input, processing it, and then giving some kind of output. Let's see. Right now I'm looking at a very boring graph, but this encapsulates a whole lot of complexity in here, and this is part of the beauty of Magick is that actually there's lots and lots and lots going on in this single graph, but it's all encapsulated within subgraphs, and then there's subgraphs inside of there, and so we're going to dig into those. So in kind of previous sessions, we had looked more at things like this, right? And so this is the chat handler. If a chat input comes in, it handles, and does a whole lot of stuff, and your graph probably looks like this. But actually, the root ELIZA graph is a lot simpler. So for our sort of cognitive architecture, we have three main inputs, and this kind of corresponds to, humans somewhat. The first input is like our chat handler here, which is just like any kind of input that comes in. We could have a lot of other, this could come in from, I don't know, reading a tweet, or someone sends you a message, or eventually we hook it up to a camera, and when it locates an image, something in the image or something, there's some sort of input that comes in, and that input is from an external source. And so we'll probably have more external inputs here as we add to this, but right now we're focusing obviously on chat. Chat is our main input. Then we also have we'll start at the bottom here, the agent loop, and the agent loop is like if we were to simulate a human, we might put breathing in the agent loop or something. We would put kind of any of the functions that we want to happen continuously in here. We might also put like a boredom counter, so that the agent gets continuously bored until they're really bored, then they do something that makes them not bored. And that could kind of drive in our agent loop. And then we have our task loop. And the task loop is about let's say somebody asks us to do something, we kind of put that on our to-do list and we start working through it when we have time to do it. We put those tasks in order and then we do one after the other. In this case, the task loop runs all the tasks at the same time, but it runs one step at a time in each task. And task could be something like checking your email or scheduling something on your calendar. And those are the two use cases we're really trying to push for in the next couple of weeks. But it could be abstract. It could be any kind of task. It could be planning my wedding, or coming up with a social media strategy or something. So these are kind of the three main root inputs into ELIZA, our cognitive agent, right? The one we're going to start with is just the chat handling, because even inside of that, there's subgraphs and subgraphs that handle additional complexity that we should really kind of dig into and understand. And if I open up the chat handler subspell again, you'll see it's here. So I'm just going to kind of do a walkthrough of what each of these pieces is, and kind of treat this like a flow diagram of what we're trying to solve. And then we're going to dive into a couple of them specifically. We're going to dive into interest and intent and focus on those. And then next time we'll focus on tasks and skills and abstract kind of handling of problem solving and stuff. But the two things that we want to focus on here are interest and intent. And interest is Well, with ChatGPT, you can assume that when a user comes to ask the agent something, the agent is always interested. They're always going to respond. But in a party or like a multiplayer, kind of massively multiplayer context, or inside of a chat room with 100 people in it, it's really hard to determine when the agent should respond. There's some obvious ways. You could just put the name of the agent, and say, if it's in the message, respond to that message. But how do you make an agent that really feels generally intelligent? That's like, they're gonna they're gonna respond. They're gonna be interested not just in things that were directly directed at them or pinged them or put their name in it, but they're also gonna be interested in something that they're a knowledge expert in, or something that's like an FAQ question that they happen to know the answer to. Or maybe they just take a stab at it because they're bored and it's been a while and they haven't talked to anyone in a while and they want to, their job is kind of to keep the Discord chat interesting or something. There's all kinds of reasons why an agent would be interested. And it's pretty easy to get an agent interested. The harder part is actually telling them to stop being interested or to ignore. And in our previous versions of these agents, the annoying thing was that if they got too interested in you, anything you wrote to anyone, they'd respond to, and it would just become this like wall of agent responses, and everything you said had some kind of weird commentary to it, and it just didn't feel. It of all the things that probably breaks the experience the most. So interest is about how we manage that, and this is kind of a field called interest management, right? And before we had all of this inside of our Discord connector, and so it just kind of automatically managed interest for you, and it worked pretty well, especially if you just like had the bot in a small Discord. But it didn't handle other things well, and it was very like timer based and heuristic based. Basically, like, heuristics are like we set rules for it to follow. And we wanted something that's a bit more natural. So that's kind of part of this new architecture. We're actually still working on the interest stuff, especially, and I think it's still a little janky, but we've come up with some good solutions for how to make the next version. But it's a big piece of this. And then the next part is intent. And intent is like, okay, cool. So I'm definitely interested in what you're talking about, but what are you talking about? And how do I best handle that request? So, if you're just chatting with the bot and you say, hey, Eliza, what's up? You might want the bot to come back and just greet you back, very simple. You don't need to start a task for that and create a whole like reasoning and planning and acting loop. That would just be really like overkill. And it would actually cost you quite a lot more. You could, if speed wasn't an issue and cost wasn't an issue, in 10 years or 20 years, like we might just delete all of this and just have everything go through the reasoning, planning, acting loop, right? But right now it's going to cost you like, 4 or 5 times as much delay for response and cost and all that stuff because you have to go through all of these different steps of thinking. And actually, when you think about yourself as a human, like when someone says, "Hey, what's up?" you don't like think deeply about it. You just kind of respond back like, "Oh, hey," you know. And sometimes when someone's like, happy birthday, and you're like, happy birthday, and you're like, wait, why did I say happy birthday back to them? It's my birthday. It's like we don't necessarily put a lot of thought into these. Sometimes we just mirror. And it's kind of just to save us, like time and having to think about it. So it's the same kind of situation in the agent, right? Like for a greeting or a quick knowledge request, or someone just wants to chat or wants help with like a little code thing, we can just do that with simple intents. And those intents might, would be like conversation, knowledge, greeting, etc. But then for more complex things, like we want to add a task to the task queue and execute it for like 5 minutes, then we're probably going to need to, recognize that as a different kind of intent. So those are those 2 areas we're going to cover a bit. I hope that wasn't. I'm just going on here about this stuff, but I hope that kind of is the overview. But don't worry, we're gonna get like more into the weeds here of what this actually means. So this is the chat handler graph. We're doing some very simple things here. Just expand this. First, we're getting the input. We're taking default input from, and this input is actually being provided by this root graph here. It goes in, hits this chat handler spell, runs it through the chat handler. Then we're going to get some values from the chat handler. Specifically, we just need to get the content out of it. So what you've seen in previous tutorials and sessions was if I want to break out the input, I would go to event destructure. I can get this. I got this giant block. I could do that, but it's kind of ugly. And if you know what you're actually looking for, this is nice because at least it's one, like these are typed. It's gonna be one of these things. It can't be anything that's not in this list for an event that's coming in. But if you know what you want, like you really just want content, you can go and use this other node, which is the get values from object, and that lets you type in like property name content, right? So I'm just doing the same thing. I'm destructuring or getting some values out of the input event, and then I'm using them. I'm gonna check content and see if there's a slash at the beginning, and that way I can have slash commands specifically for things that like debug things like adding a skill or adding an intent or an interest, and we'll get into that in a second. I'm gonna create a text embedding of what what's coming in from the user. So if the user says, "Hey, what's up, Eliza?" I'm going to create an embedding of that. And the goal of the embedding, well, we're gonna use it for a few things, but it's super useful for intent recognition and interest especially. And that's why we're just going to create that up front, and then we're going to pass it around. This exclusive gate isn't really doing anything for us right now, but we will have cached embedding handling, and so this will get used. We'll just add something to there, and basically that would get the embedding from the database if it already exists, and then it'll create it if it doesn't. Whereas right now it just creates it every time, which is a little more costly than we'd like. Embeddings are like 1/100th the cost of your LLM calls typically, so that's why we try to do things with embeddings, even though we could do them with an LLM. Like we probably don't want to run the language model for every single message that comes into every Discord the bot is part of. We can run an embedding for every message. It does have a cost, and in a really large Discord, it's definitely going to cost something. But generally for like, if we're paying $1 for 10,000 messages or something like that, it's totally fine, right? More or less. And we're getting, those messages are going into long-term memory, and we can use them all over the place a lot. And for the things we're about to do. So that's kind of what we're doing here with the embedding. We're passing it through to this gate, and we're just going to store that input right off the bat for the user as part of the conversation. So they said, "Hey, Eliza, what's up?" Let's store that in the database. And we've been doing this, obviously, in the Discord and other previous sessions. We're going to take that event, that input event that we have here from the event, and we're going to add that embedding into it. So the like events that are incoming don't have an embedding associated with them yet, because we have to create it, with this node. But we can merge that embedding back in, and so that's what this merge objects node does. It takes the input event that came in, which is this object thing here, and it takes an embedding and adds the embedding to it, and then it merges it together, and then we have an event that has an embedding. And the reason that we're doing that is because then we can send the embedding in with the event to these other subspells. So once we've got the embedding, we merge it into the event. We cast that object right here. This is a cast, and we cast that object back to an event type because it will work. And then we can use that in other places. So the idea of casting is something we haven't talked too much about. But basically, we have these different colors of nodes, like the orange one is for string, and the blue one is for array and stuff. And sometimes you need to just get one to be another type, especially if they're complex types like the event type. So the cast basically takes any type and then turns it into another type. Obviously, this could cause problems if the types don't really match. So that's why it's its own node, is because you really are consciously doing this, knowing that you're changing one type to another. That actually an event is a type of object, and so that's okay. Casting an event to an object or an object to an event will work all the time. However, casting a string to an event or a string to an object might not work, and so you should be aware of that. And basically, the heuristic here is like a string or a number or any of those will cast, and any kind of object, anything that has multiple values that you could add together or pull out of it, get values from, will cast to each other as well. If that's over your head, don't worry about it. You rarely see this, and you could probably get away without it even, but it's just the proper way to do it. So we've hold on. I don't have two screens here, so sometimes it's hard to see if I'm getting feedback. I'm going to cool, getting some messages in the background, but seems like we're all good here. Okay, so we've gotten through the kind of basics of control flow and moving stuff around. We got the embedding. We stored the user input with the embedding. We put the embedding on the event, and now we can actually do stuff with the event and the embedding. The first thing that we do is we have this find interest sub module or sub spell, and I can open that up. I can see it's here, and so this graph right here that I opened, this one, is this subgraph right here, right? All those nodes are contained in this. And what's going on here, this is a very basic version of our subgraph, right? We're going to do a lot more with interest handling, or maybe even just train a custom model, or I don't, we're figuring it out. But the most basic version of this is, do we want to respond to the agent, to the input, or ignore it? And the way that we do that right now is we have these stories. And let's say, well, how do we want to get into this? So we've talked about embeddings before, but I think that it's hard to have a really good grasp of like what an embedding is, right? So let's just say, hey there. I wonder what that issue is. Let's see. Is it something I can fix, or we're just gonna skip it? Error. Oh, right. It doesn't have an embedding. Well, that would make sense. I could call it from the external one. So we'll just go over it. I don't think I can test it directly in here. So what, like, we use embeddings to, you're used to searching for things by words, right? Like, hello there, right? And you might go and say, okay, well, I could imagine that for a search engine or something, it's going to go look through every document that has the words hello there. But hello there is also a greeting, right? Like hi there, hey there, hello there. They all mean the same thing. They all have the same sort of purpose. They're all greetings. There's something conceptually very similar about all of those, right? Like they're not really that different. But the words are different, so how would you relate those together? And large language models, the way they work is they kind of put everything into this multi-dimensional space. But think about it like three-dimensional space, in your head. And you just kind of put all of the concepts that are similar to each other together. And so hey there, hi there, hello there are all clustered very similarly. And so if we wanted to know, is the user greeting us, we could probably create a collection of embeddings like, hey there, what's up? Hi Eliza, and store them and then kind of use them later for similarity to whatever the user's input is, right? Does this make sense? The user says, hey there. we don't have a story for hey there, but we do have a story for hi there or hi Eliza, and it's like 90% similar conceptually. So if we get back a story that, if in our database of stories that the agent knows to respond to, we have one that is mostly similar to what the user said, then we can definitively say they're greeting us, and we should probably respond to that greeting, right? I actually have another graph here, which hopefully, yeah, this one will work at least. We might need to add like a respond node to it. But we do have the find intent and find interest in here. Cool. So we can at least use this. Here I have a broken down version of the chat handler spell, and all it does is it handles creating the embedding, and you can see it's kind of the same merging objects, but it's just really focused on this interest right here, right? And so if I create a respond node, hopefully I'm off on some crazy branch right now, so hopefully it works. And you can see, okay, cool, great. So I typed hey there, and you can see the agent decided to respond. That's because I have a document which corresponds to a greeting, which, is the embedding of the document is a greeting, which corresponds to the value respond. And if I go into my documents view, this is still very, we're working on this. It's very programmer art right now, but it gives me the basic stuff that I need to know, which is I have these values for interest. Sorry, I can't really read that. You can see I have one, and the name is respond, and the description is hey. So I have the embedding for hey, right? Which is this crazy number here. This is the embedding. I have the embedding for hey, and I have the name respond. So if you say hey, the agent will respond. Now I also have an interest for ignore. And you can see the description is shut the hell up. So if you're really annoyed at the agent, maybe we want to ignore that message and not respond to it. So those are the obvious cases, right? And I could say, hey there, respond, shut up, ignore, be quiet, ignore. I don't have a story for be quiet, but conceptually shut up and be quiet are very similar. And therefore, the most similar document that's coming back is the one that has the value for ignore. And maybe what's going on? Respond. Now it's pretty good. It like just in terms of basics, like with a few stories, it's pretty accurate. The reason that it doesn't work for us is, well, we could add some heuristics too. We could add like if they say the agent's name in their message, well, we should definitely respond to all of those. If they say please stop talking or anything remotely close to that, we could have some list of things. We could definitely, even without checking embeddings or anything, we could just not respond, right? You could imagine that. And we could do these kinds of embeddings for this. But how do we get beyond that for like, you're in the middle of a conversation and the agent needs to know that you're in that conversation. So we could have like a timer and an interest timer and all that stuff. And we had that, but it doesn't always work. And the main problem was it was kind of hard to determine when to stop talking. So now we're working on more of a neural network approach, doing what we're calling second order embeddings, where we're like creating a relationship between the two embeddings, blah, 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 blah. It's a whole thing. That'll be coming. But basically you can sort of hopefully kind of conceptualize how you could be working on your agent and dealing with the same problem. You've got this like fire hose of messages coming in, and you need to determine which ones to ignore. And you could maybe say, have some heuristics like, well, check if the agent's name is in the message. If it is, then great, you're good. Or if they have a slash at the beginning, then always respond to those or something. But you might want to go a little bit beyond that. And so that's where this kinds of interest stories start to make sense. I'm gonna come back to the specific. Well, I don't know. I'll go over this graph and then we'll kind of go into intent. And intent is actually almost the exact same. In generally in like a chatbot context, you might not see the interest because the chatbot's always interested, but you'll always see intent. That's like a very important part of a lot of these kinds of like everything from Amazon Echo to Alexa to the latest kind of GPT chatbot stuff. So for interest, it's quite a simple thing programmatically, but because we're using nodes, we're doing a lot of like, you can see I'm getting a value, getting an object from the value, converting it to JSON. It's a lot of like one line of code things, but that we have to do to sort of transform the documents. So we get the input, and the input here is an event which contains an embedding, right? This find interest is actually inside of this chat handler, and it's getting past the whole event. We are going to get the embedding out of the object that's coming in, because that's really what we need to search. And then we're going to use that embedding to do a similarity match against documents in our document store. And the type that we're looking for is interest, right? Only find me interest documents. And, we have a max count here of 6. It could probably just be 1. We only really need the last one for this. The most similar document. You could imagine getting like 3 documents and then doing a best of or, all kinds of stuff, whatever. But I just need 1. We're going to get the first value from the array of documents. So when we said get documents, it gets us a bunch of documents or just 1. But that's going to come in as a list. And we really just need to get one of the items out of that list, the first item. Lists and arrays are, for most intents and purposes, the same. They're handled slightly differently, but for the user, you as the end user don't see the difference. So you imagine you have a list of documents, you just want the first one, and that's what this get values from array does. We get element 0, which is like the 0th item, because we 0 index arrays. And that would just be the first document. Element 0 is the first document. We're going to get that out of there. Then we're going to get the content of that document. The content of that document is the actual like data field, of text. That's the actual document text basically. We're going to take that data field of content and we're gonna turn it into an object. So you can't just do this with any document. It has to be a specially formatted document. And if I go into my documents, you'll see that for like this interest ignore, the document actually has a structure to it. And this is called JSON, this notation, JavaScript object notation. Object notation is the ON, that's the key part. It is an object, but it's written as a string. What that means is that it's just like normal text. It doesn't think it's code or anything like that. But later, if we want to, we can interpret it as code. So we can say like, this is a key, this is known as a key value store in this case. The key is the name and the value is ignore. The description is the key and shut the hell up is the value here. Key value, key value, key value. And so what we want to do is get the value of the name, right, to know whether we should ignore or not. That's kind of what we need to do to handle the interest in this case. So we got the document, we got the first document from the list, we get the content of that document, which is JSON in this case. Not all documents are, but the ones we've been storing are JSON. We convert that to an object, which we can use like as a JavaScript object. Basically, we can get data out of it. It's an object. And then we get a value from the object. And the value that we're getting is the name value. And so if that is ignore, we will pass ignore to the output. If that value is respond, we'll pass respond to the output. So we could have a bunch of other nodes in here. I think like I'll show you one example of something we could do, which is let's say we want, okay, we definitely want to check if the agent's name is in a message, and then we can just definitely respond. But if the agent's name is not in the message, we should go through this list and do our whole like story handling kind of thing, right? So how are we doing? Yeah, I guess we're doing okay on time. I might say, let's say, a text rule matcher. And the text rule matcher will look for, I can create all kinds of different rules, but I just want to say, is Eliza in the text, right? And I can match any, like that, right? Eliza, Eliza, Eliza. Cool. And if it is false, we will go through that whole long process. And if it is true, then we will pass this to the output. I can use a text template for this. I'm using the template because it has a trigger instead of a text variable. I could use text variable as well, but the template has a trigger, so it allows me to kind of trigger control flow. And I'm going to say respond, right? Definitely respond in that case. Cool. Now I've sort of hardwired, if you say Eliza, this graph will say, yes, you definitely won't, this should definitely respond. Now we can like create a public variable, expose the public variable. You could enter your own name, doesn't have to be Eliza. And we'll probably do that for future versions of all of these graphs so that it's super customizable. But just like, you know, if you're selfishly working on your thing as fast as you can do something like that. Use the text rule matcher, match any of these names, and then pass it through to respond, right? And you can do the same thing for ignore. You could say shut up or whatever, be quiet. Those are probably things, you know, if someone's saying that, they probably want the agent to stop talking. Cool. So that's interest, right? I hope this kind of makes sense. We have hard-coded, super obvious heuristics. Then we have cascade back down to, you know, these sort of or interest recognition stories. And what we're going to do last after this is we're probably going to do a similarity score check on the actual document. And if it's below a threshold, we'll go and like ask our LLM to evaluate it or something. And we might do that just to collect all the data so that we have good quality data, and then we could probably turn this whole thing into a single model in the future. But for now, this is kind of, you know, this is the easier thing to do. Okay. Sorry that was a mouthful. So coming back to the root graph, you can see that once we've found our interest, we pass it on to this switch. And the switch has ignore and respond. Those are kind of the two handlers. We also have a default on the switch. And if for some reason, like if you had an undefined, your interest didn't come back right, or there was a bug or something, you might want the default to like go down and throw an error or something and say, hey, it's not working. I don't know what's up. You know, we could even plug that into the ignore, and that way it gets passed along. Once you've found, let's say you're ignoring, well, that's it. That's kind of the end of your journey. We have a debug in the Eliza graph to say, hey, I'm ignoring, just so that we personally can verify that. But generally, you're hoping that the agent responds, right? That's where things keep getting interesting. So beyond the interest, we have our intent recognizer, and intents are a very old thing. Like the idea of an intent has been popular in natural language programming stuff for a long time. Alexa skills are tied to intents, as are like Android kind of any sort of thing you want to enable for your Android is also called an intent. There's a lot of it's a common sort of programming idea in this sort of field. So generally, what an intent is saying is I either want to have this capability, which would be like the Android case, or I want to handle this skill. I mean, I want to handle this input like with a particular skill. I'm trying to, how do I phrase that? That would be the Amazon Echo way, right? Like you register an intent to a skill. So a skill might be like, change the song on Spotify, and the intent might be, hey Alexa, change the song on Spotify. I don't, well, it would have different ways of recognizing that that was your chosen intent. And so in Magick and in Eliza, we're using intents in a very similar way, where I will open this up. This actually looks almost exactly like the interest graph right now. And that's because, one, I basically copied and pasted one to the other and patterned them very similarly. And two, it's basically doing the same thing under the hood. We're getting an embedding that comes in. We're finding a document that closely matches our intended intent, and then we're passing that back, the name of that document back. So, looking in documents, you can see we have these intents, and so one intent is conversation. And I just have a bunch of different stories. There might even be different stories for conversation. Yeah, there are. See, there's like, I'm chillin', yo. Or there's an intent for greeting. Hey, what's going on? There's an intent for knowledge. Can you help me with a code thing? So each intent has its own intent handler. And we can have multiple stories, multiple documents like this, per intent. You don't just have to have one, hey, can you help me with a code thing? You might have like, tell me about yourself. What is Magick? Where do I find the documentation? And those might all map to the knowledge intent, for example. How you feeling today? What's going on? Those might be conversation intent, or greeting intent even. Or, the last one would be the task intent. Like, hey, can you go check my email and see if I have anything new and interesting and summarize it for me? That would be a task intent. And we have, like, here's one right here. Can you check my email for me? That's the task intent. And so we could have a lot of different intents. The goal is that you can actually add your own intents, not from this UI back here, but you can tell the agent, like, can you add an intent for greeting that is like, the text, hey, what's up? And it can analyze that and do that for you. Right now, the way that we're adding intents and interests is with our / commands. And that's what these are up here. So interest, do I want to respond to this person? Intent, how do I want to respond to them, right? And then I have these different intent handlers. So I'm in the chat handler. The chat handler calls the find intent, which returns the intent of let's go use knowledge, which is like search our long-term memory and return a long response. That calls the actual spell for that intent handler, and then we respond with that information to the user. But in the course of this, you probably want to add your own intents, not by going to the documents, but by actually just like typing something. So for Eliza, the way we've done that is we've created these / commands for like add intent. And the add intent handler is here. I don't have to go too deep into this, but it's basically looking for / add intent. It has a text rule matcher, and it matches the beginning. If it matches / add intent, it goes through, it removes the intent, it gets the first word and makes that the intent name, and then takes the rest of it and vectorizes it and stores that as an intent document. So you can see it creates text embedding, does some code stuff, basically creates an object, stores the intent as a document, and then returns, hey, I stored that for you. That's all that's kind of happening here. And the add interest is the same way. It's the exact same thing. It's just adding an interest document. So the reason I have these is so that when I go to my Magick research here, I should have like yeah, you can see I have like add interest, respond, hey Eliza. And then when I say hey Eliza, you can see it caught the intent greeting. I don't think I was logging the interest at this time. Let's see if I have another one. Slash add intent. Slash add intent conversation. I'm chilling, yo. And the bot wakes back up. And I say, hey, Eliza, what's up? And then she says, I'm doing well. And I'm trying to find some other good examples. Here's a good one. Add intent knowledge. What is Magick? Hey, Eliza, can you check my email? I'm starting a new task objective. Oh, that's probably still... I don't know, these are all okay, but you get the idea. That's how I'm doing. I'm saying slash add intent, greet Eliza. Add intent knowledge, what is Magick? And those add these intent documents to the background so that I can just, without having to go into my agent and edit the documents and stuff, I can add those as I go. And so I'm adding them into this concept space, and as I add them, it gets more likely to find one that's closer to what it's looking for, and so if I have a lot of documents, it has a fair amount of accuracy of what I would probably want, as long as the documents are right, Cool. So let's see. We're going to recap this a little bit. I think that's probably been a lot. Oops, there we go. I'm going to go here. We're just going to do a little flow recap over this, just kind of from front to back, now that we understand what's going on here. And then I think we'll probably cap it there. I think next week we're going to talk about, maybe I'll show you a couple of intent handlers as well, and then we'll cap it. And then we'll talk about tasks and everything related to tasks next time. And also this whole thing, all of this stuff that I'm going over, this will be available by default in Magick pretty soon, and you'll be able to download the project. We have the project up for you right now, but we're just working on fixing the importing of it so that you can import it without breaking anything as it gets imported. Real quick, the input comes in from the Eliza root graph. It lands here in the default input. We get some values from that input, specifically the content of it, what the user actually wrote. We look if there's a slash command, and then if there is, we go and look, well, is it slash add skill, slash add intent, slash add interest? And if it is, we handle those by actually adding those as documents. If it's not, we're going to go on to create a text embedding of what the user wrote. We're going to pass the embedding back to merge it with the input event. And then we're going to pass that input event around. That way we don't have to continue, create the embedding again later. And we can pass that event into find interest. Find interest will say, should we respond or not? If we should, then we will come along to find intent, which will do another similarity matching. And that intent will then determine what spell we call. It's going to give us back the name of a spell, and we're going to use that name to call a spell by name. So here you can see we have these subspells, which are embedded spells, and those are fixed. You can, it's just one spell that gets called. The spell by name lets us call any spell we want as long as we know the name of it. So this will handle the different intents, right? Like knowledge or task or greeting, or maybe we have profanity response. I can't respond to that or something. We could also have intents for profanity and things in there too. And then once we've run that, we will let the user know with this is some debug response. But if the spell returns something, it returns a response, we will store that in memory as part of the conversation. You see at the end we're creating we're creating another text embedding of the response, and then we're storing that. And if it doesn't have a response, it'll just it'll end there. And that is our basic chat input graph. Okay, I think it would be good, given that this was a pretty complex overview. We didn't really do a lot of example stuff, just kind of talking and going over some of these nodes. Maybe do a little bit of Q&A and kind of see how people are feeling on this. I'll switch back to our room here. Quite a lot of chat. Any questions here that you want to answer? Anybody want to hop on stage and talk about it too? There's a couple of papers that are pretty big on, like, definitely relate to this, and maybe we'll post them. One is reasoning and acting, React paper, machine learning, synergizing reasoning and acting in in language models. And there's also a Google blog on this one. This is probably a good one to post. One of the things, this is heavily influential on what we're doing. Honestly, I didn't read this before figuring all this stuff out, but it kind of validated a lot of it. And I think it's pretty obvious for if you're kind of in this space and thinking about how humans think. But the big part is they said, okay, well, we have this idea of chain of thought, right? We can take stuff from one part and pass it to the next part and pass it to the next part. But how do we actually like act on that in a plan and act on it in a world, or practically doing stuff, not just thinking about something, but also like putting output back into the world. And so React, the idea was like, well, we can reason, but if we fail to reason or we're not sure of something, we could also like go search the web, or go check our knowledge base. So you can see they have kind of a loop of like, you can reason in chain of thought, or you can sort of do an acting and observation thing, or you could actually combine all of this and you could reason about what you were doing, then make actions, take observations of that, reason about it, make an action, take an observation of it. This is a really good paper. It shows a lot conceptually of like some of the sort of like how the tasks are laid out. And this is pretty similar to a lot of what we're doing. The other paper that I think is very influential is the generative agents paper. And we'll post both of these to the chat. Interactive simulacra of human behavior, right? And so their idea here was they took kind of the reasoning and acting learnings, and they said, okay, cool. Well, now let's put them into a 3D or 2D world, and let's have them talk to each other and actually build up knowledge about each other. So some of the stuff is kind of hard-coded. Like they give each of the agents its own, like you live in this house and your name is this. And it's not like emergent, but a lot of emergence happens even from within that because these agents are sort of walking around and talking to each other. And I'll post some of these. Cool. If anybody wants to hop on stage, I think we can do a little bit of Q&A or anything that I could kind of help with. Or if you have any questions, even more generally about, I don't know how to bring people up. Let's see. There we go. How's it going? How do I'm gonna invite some people. Here we go.
Hello?
Hello.
Okay, it works.
Yeah. How's it going?
Yeah, it's good, guys. Just been listening and chatting there. Quite a discussion.
Yeah.
So, yeah, been stoked. Well, I've been on this Amazon summit, and then I tuned into Google I/O, and they're on the keynote and this, and I'm like, Magick logo pops up. I'm like, oh shit, like we're part of something huge here, and wow, I mean, congrats, guys. Looks like you're doing, I mean, great stuff there, right?
Yeah.
We have been busy.
Yeah. I was like, damn, because like when I started attending your sessions, I just thought, okay, there's just like a bunch of guys doing this for fun, and then you see somebody's
We can be
startup
both.
just popping into that most coveted LLM. I was like, wow, okay.
Yeah, we're definitely still just a bunch of guys having fun.
Oh yeah,
Yeah,
yeah. I
that's
mean,
good.
most of this came out of somebody that I had been founding with last year, that I'd been working with, left on really good terms, and he started working at Google, and he was chatting with one of the VPs of engineering over there about what we were working on, because they're working on AI tooling for developers too, and so I got together with him and we just started nerding out. And that's really like kind of where it came from, was just nerding out with some Google people, and they're like, "Whoa, you guys are doing cool stuff," and we're like, "Yeah, you guys are doing cool stuff too." So we're still doing cool stuff. Turns out that they get what we're doing, which is actually really great. The idea of AI developer tools that are not made for like ML engineers, but made for engineers and makers, is I think something that people are still queuing into.
Um, Moon, I had a quick question.
Yes.
So, one part of the React paper that's still fuzzy to me, and it's still kind of fuzzy to me after looking at this ELIZA stuff. When the part of the React loop happens where it like decides on a task to take, how do we translate that into an actual thing that happens in the real world?
So the React paper, and this has been expanded on if you look at LangChain's stuff, the concept of tools is very big in the agentive world right now too. But basically, with the tool paradigm, or with the React paper, it's given an explicit instruction on what things it has access to and what it can do with them. So in the prompt space for React, it says, if you need to find information, you can search. And this is how you search. It's basically a function that takes in some argument. And behind the scenes, they're parsing out that function, actually calling a real function that does a real search with whatever term the LLM has decided to search for. And then they're getting the content and injecting it back into the context. And so then on the next loop, the LLM gets triggered off again. And now it had the reason, it had its action it decided to take, and it has what the React paper calls an observation. Right, so the observation is the result that was returned back from the search, and then the LLM is given the opportunity to reason over the observation again, to decide if it thinks that there's enough information, if there's not enough and it needs to do a further search. So it has the ability to autonomously make new decisions and access different tools to accomplish in the case of the React paper, just a question that it's been asked.
So I was going to go over this next time, but I think that it might be good to go over it now to understand, like, most things are probably tasks. When I'm, like, most useful things, when I'm casually chatting with the agent, a lot of times we're just trying to sort of shortcut for it to respond quickly and say, oh yeah, cool, you need a quick answer to something, right? Like, if you want to know what a Boolean is, we don't need to go do a whole task to do that. The LLM knows what a Boolean is. It knows better than than I do, for sure. So there can just be a simple response. But for any kind of complex task where we have to go to the outside world for information, we're going to create a task for that, and we're going to go through our task loop. So I showed you our chat input loop, and one of the big intents is to create a task, right? Like, a lot of it, basically, if you said, can you check my email? Can you write a tweet for me? Can you plan my wedding? Whatever. It's going to create a task. And the task is not respond. It'll tell you maybe that, like, okay, cool, I created a task for this just so that we can, like, debug it. but it's not gonna like go hit the LLM and respond immediately. It's gonna go do a whole lot of stuff. And so this is the task handler loop. And so once you've created a task, which is an intent, right? So when it detects that you want to create a task with the intents, it will create a task. Maybe I'll go there first. We'll look at the intent for what is it? It's a module, and it should be, I forget what they're called sometimes.
Skill?
No. Eliza intent task. Okay, so what the task does is says, okay, I'm going to get the most recent conversation, and then I'm going to generate a task objective for that conversation. I have some task examples, and this is kind of a task description. This is the prompt for the objective generation. We're going to generate an objective using the generate task text node, and we're going to pass that into a create task. And so that creates a task with this objective, and the task is now on the task queue and will get run. We have tasks are in here. I don't have any good ones here, but you can see that tasks are just listed in here, and they're either active, completed, or canceled. So these are active. If I went to my agent and I enable the task runner, these will start running all the time until they're finished. And tasks can cancel themselves or complete themselves or run out of steps.
So in like our case with Eliza, would we give like the task graph our like list of tools that are available to it?
Well, that's the next thing. So we've created the task objective. It doesn't know anything about the tools.
Example task, Moon?
Yeah. Yes, but so we've created the task with an objective, right? Now, each step is going to require a skill to execute that step, right? A task is not just like go search the internet. That's going to be like, okay, maybe ask the user more questions about what they're looking for to get more information because we don't have enough. Then go and use the web browser skill and get the information on the page or whatever. Then summarize it. And it may before all of that, it actually planned all of this with the planning skill. So just imagine that like we've created a task and it has an objective. It hasn't reasoned about it or anything. It's just kind of started the task. We go back to the task handler. The first thing we do is we reason about the task. If it's the first step, we might start planning. And you can see we have a subgraph entirely dedicated to, let me close some of these, just to reasoning. Should.
If you're on the new branch, you could do control period to center the graph.
It doesn't work. It might just be empty. Hold on, I can fix that. Let's just
let's say if I wanted to give Eliza, we call tools skills, right? If I wanted to give Eliza a new skill,
there we go.
How would it like discover that skill as part of the task loop?
So
like,
this is did I fuck up? Hold on. Give me 1 second. Eliza module task reasoning. There we go. Okay. So, right. So those would be skill stories. So we'll get there in 1 second. The first thing I want to do is I want to reason, okay, what am I trying to do? If it's and I have a prompt here that handles reasoning, and we can say, well, if we have more than, if it's our first step, we might want to try and plan it and say, what is the first step? If it's not our first step, we might be continuing, so we'll have information that we'll inject in from the previous steps. The first reasoning is usually I should plan out what I'm going to do. Okay, it's going to generate that reasoning. I should plan out what I'm going to do. And then we're going to create an embedding of I should plan out what I'm going to do. Right? We're going to create an embedding of the reasoning, and we're going to match that to a what we're calling a skill story, or basically a document. And just like intent recognition, we have skill recognition. Skills are like almost like sub-intents, right? And so a skill would be search the web, or check my email, or post an email, send an email. And each skill has its own language model handling, because it needs to just take in all of the previous steps and then handle it. And we can't. This is one of the key differences between us and LangChain, is that LangChain exposes tools. And they say, okay, well, you have a tool like web browser, and it takes these inputs and these outputs, and then just run tools in a loop. And what we're saying is that would be great, but there's actually a lot more complexity to using a tool. There's like a lot of little detail there, and so we're using like tools inside of a skill. And so a skill is just another graph, and that skill graph would handle like running the actual skill and returning something, and then we reflect on that, on what we've returned. So we reason about it. We find the skill that's appropriate to that reasoning. I should search the internet. Oh, I have this internet search story. We run the skill that's associated with that. We get the output of that, which is the observation. We then reflect on the observation and in context of the whole thing, which also gives us a like pass or fail for the step. And then we store the step in the task. Then we run the whole thing over again. We reason, we pick the right skill, we run the skill, we get the observation, we reflect on it, we store it.
Where what node receives the observation?
The reflection node and the task step node.
Okay.
So it's stored.
The observation. It would depend on like what skill we're using, what the observation would actually be, right?
Yeah, but it's always a large language. Like, it's like a language thing. The observation would be like, yeah, I returned a summary of this, or so I can show you. We don't have all of our skills done yet, but I can show you like a simple one.
Something concrete just does help me understand.
So like the planning skill, right? Planning skill, all it does is it calls a particular prompt with a particular language model, like thing, right? There is a prompt which is like, given the objective, last steps, and reasoning for the current step, write a detailed plan for how to execute the task and complete the objective, right? That's all it is. Then it writes a plan, outputs the plan, and that becomes the observation. We then take the observation, store it, reflect on it, and run the reasoning for the next step. Another skill would be completing the task. Right? Oh, I mean, obviously we've got to fix this. It's totally trashed. But all it does, it takes in the input and completes the task. It's literally that simple, right? And then the task ends. So we have documents that are associated with our skills. Like we have a complete document, which says, I have completed the task successfully, right? Okay, if the agent returns, I'm finished with my task, it will probably call the complete document and then call the complete skill, and that will be the last step of the task before it ends. Does that make sense?
Yeah, that's pretty clear now.
We also have like a cancel task. I did not complete the task successfully, so I should cancel it. Or long-term memory, web search, all kinds of evaluations. Checking my wallet. Could be anything.
The way I like to think about it, we're kind of doing the opposite approach that things like LangChain and some of these other systems are doing, where they put the tool and the tool description directly into the context. We're saying, well, there could be 1,000 skills. We want the LLM to state what it thinks it needs to do next as the next step in its process, and then query our skill space for user stories that match that. And maybe it gets 5 different tools. We can put those 5 tools into context and let it choose which one it thinks is best to accomplish the thing that it's trying to accomplish.
Right.
So you very quickly get a limitation on you're telling the LLM you can only use these tools. What we really want is we want the LLM to state what it wants to do in the ideal world, and then match that to things that we have given it the ability to do.
Right. Now the future of this is we are defining enough graphs that it has relatively good amount of functionality, but it should be generating its own skills. So we need enough data to do that. But if it comes to a low confidence thing, or like I failed at this step, however, I think I could generate, I could probably figure it out on my own. It could generate its own graph using an LLM that's fine tuned on all of our graphs to solve the thing independently. So now it's not just selecting from whatever we shoved into it, it's creating its own solutions. We just can't do that yet until we have all of this tight and we have enough data collected to do that. But the goal here, again, the whole goal of this version of ELIZA is not to be the AGI, it's to create the data for the AGI, right? I don't think I've said that before, but I should say that before and after every time I introduce this project, because we need to make clear that the goal here is data collection. Once we have data collection, it's kind of like a self-driving car. Like once the car is driven enough miles, you just have all of the sensor inputs and outputs, and you can train a model on that directly. And so, we need to reinforce what's going on here with reflection and all of this stuff, because we need the agent we're not really that confident yet, and while we're spending some extra LLM calls to reflect on how we did, that in the literature increases the like success rate by like 50%. It's a marked improvement if you reflect on your observation in your loop, and and if you reason before you do this stuff. So that's kind of the thinking here, is that like this is all data collection for the generalized version, which just solves the dang problem. It just invokes whatever function it needs. It can generate graphs on the fly. Does that make sense?
Yeah. Cool. That's like the long-term plan.
Yeah. A data bootstrapper to smaller models. Cool.
I think we know some people at Open Assistant.
Do we know anyone? Yeah, isn't Hu Nguyen's deep in Open Assistant? So is Arena Riche. What they're doing is awesome, and the actual LLM we could totally use. The only reason we haven't is just like the lift of starting up the stuff. Yeah, I mean, they have all their data. We could, they have a full RLHF data set and all that stuff. But we would probably in that case be, the main benefit to us would be like fine tuning the Open Assistant model or something like that. It's just a deployment issue. Ultimately Google and OpenAI make it really easy for us to not leave. And the other thing is that, we rely super heavily on embeddings, so we would need to make sure we have like the embedding model, all that stuff deployed. I think that I would love to do a Magick Open Assistant thing. I'd love it running on a box. Like that's my dream. I think, I follow their stuff. I'm definitely long-term very bullish on them. We would just need to figure that out. And really, if anybody in the community wanted to do that integration, like, oh my God, that'd be awesome. I think it's just an interesting. I mean, Ben, this is exactly the thing. It's like, if we can maximize iteration speed for users so that users can go as fast as they possibly can to build new graphs and share them, then that's the secret. It's not like some insight into psychology that I come up with. It's about some random that shows up and brings that to the table and then shares it, and then we all have it. And then we can, share those skills, and just like the human neural network of improvement is there. We're all learning together. But then there's also the like actual, like we train these into a really serious graph generator.
Mm-hmm.
Cool, friends.
You'll notice that the two goals that we have is the architecture should be modular enough that members of the community can just like, hey guys, I built a new reasoning module. Check it out. And you can just like plug it into where reasoning goes. Or people just want to build skills. They don't care about, we call this kind of the root graph, but there's like, if all you want to do is build skills, we can have a bunch of people adding new skills to, operate inside game worlds or plug into Unity or whatever else you need your agent to be able to do. People can just focus on making skills for those. So there's kind of like levels of participation where people will be able to collaboratively build a single awesome agent in pieces and swap it out and share their different solutions with one another. I think that's really where I see the community side of this coming in, is like, yeah, we're all going to be building all of this together.
Yep. I imagine
Yeah.
we could collapse all of the interest, intent, and all this stuff, like which skill we use, into one model pretty quickly.
Mm-hmm.
So I look forward to that, and then maybe we'll serve that, and everybody can just plug that in, and your graphs will be like way smaller. But cool. Everyone feel good? Feel like we covered some good stuff?
Yeah, I mean, this is the stuff that really gets me going.
Yeah. I'm excited to go back and work on it.
Like, just for context reveal, this is why we built Magick in the first place. Like, me and Moon were talking about this like almost 2 years ago, and like it was really for this level of complexity and this kind of problem that we built this for, because this is what we wanted to do with it.
Yep.
It's actually really awesome to see it actually happening and being put into practice.
Yeah. So we'll be making this available to everybody hopefully by tomorrow, but probably end of the week if we have some other bugs, just to make sure that it's shareable. And we'll be really focusing on making it easy to share and work on, and probably add some more detail to each of these pieces too as we go.
Yeah.
Cool.
I think all those little UX things of like, how do I build just a skill?
Yeah,
Like,
exactly.
How do I run just a little subspell? But you already had it come up with like, oh crap, I can't actually run this subspell right now. I need to go to the parent spell to run it.
I think
Like, these little things.
developing skills should be our next week.
Yeah.
Cool. All right, guys, I'm gonna hop off. It's been a long one, but great hanging with you and working on this today.